Hey everyone, welcome on in. Good to see ya. Hey Quick Fix, hey Radio. You guys got here right before the stream started. Welcome on in. Good to have you here. We're going to continue with our variational autoencoder, which is definitely quite an adventure. There's a lot of things that we got to take care of here. All right, get status. Where are we at right now? Okay, so let's see here. RMC. All right, looks good. Okay. See here, 1 second. This is our present working directory right there. I want to get everything set up here real quick. Desktop, Rust candle, RM. All right. There we look. Looks good. All right, getting things set up, you guys. RM. There we go. Okay. All right. Now open up our source file. Yes. All right. This is where we left off. So we need to do quite a few things. Actually, I'm not even sure what we need to do. All right. So we got our encoder. We got our config. We've got some FC layers. We need to get some extra things here. Yo, Xander Edits. Welcome on in. Good to see you. Hi. Happy Tuesday. Good to have you here. We are continuing with our variational autoencoder today. And I need to figure out where we need to go now. Right. I remember now. Hey, Richie, welcome on in. Hey, pal. Good to have you here. Happy Tuesday. Stretch ESP32. That's a good one. Right. Let's get some hardware in here and do some microcontroller processing. We could do that. ESP32, yes. First like done, Ruchit. Thank you very much. Let's see. So we got our load image. That looks good. We've got our cat, and we finished the feed forward. Yo, Ruchi, thank you for the 100. My gratitude to you. That's awesome. Appreciate it. Good to have you here. Hope you're doing good. Thank you again for the 100. That was awesome. That was probably like one of the most recent. What do you call it? A record for like I start stream and you immediately within 2 minutes. 2 minutes. Hey, Ali Azizi. Good to see ya. Welcome on in. Hope you're having a good Tuesday so far. Bonzupi, welcome on in as well. Good to have you here. AW9Q. Hey, Steven. Nice to see you again. It is nice to see you as well. It is nice to see you. Good to have you here. So cargo run. Let's see if that builds. Yeah. Are we building? All right. We get it. We're in a good spot. Hey, Muga fan. Good to see you. Welcome on in. Bon Jovi 97. Yep. That's some artist. That's a music artist. They play music. They play music because it costs 2 diamonds, pal. Well, Ruchi, thank you very much. Nice. All right, good to sketch Python. We're doing some Python. Good. Nice. Yeah, right, Bonzupi. Nice to see you. Hey, From, welcome on in. Happy Tuesday. Good to have you here. Why weren't my message saying that on Twitch on your chat? I saw. Well. I don't know. You're asking questions that I'm not familiar with. I do not know the answer to that. I am curious though. If you learn about it, let me know. All right. So what we're going to do is we're going to continue with our feed forward. We need to pass more of our data through our network that we've defined here. So we got more network to do. Warm regards. Nice to see you. Yeah, and the list goes on. All right. How to make the AI. We are going to, you mean the AI that we're working on right now? That's going to make a picture of the cat? Why are my messages not showing up in the Twitch? I don't know. I don't see them. That doesn't make any sense. That's complex grammar. A little bit, right? It's a little bit complex. How to make the AI. We are going to be basically doing a bunch of math operations to do matrix multiplications. And it's just a lot of matrix. It's just a continuous amount of matrix multiplications, specifically even with the convnet, the conv layer, as a projection through a whole bunch of filters. And a bunch of filters. Yo, how's it going there, Karthik? Welcome on in. Turberkio, good to see ya. Your dog is called Loki. Your new dog I saw in Discord. Over here. I saw a picture of dog. There's a yo, Joe. Good morning, good afternoon, evening. Hope everyone is well. Joe, good to see ya. Happy Tuesday. Hey, Sergio, welcome on in as well. Sergio, Tubercio, we got Quick Fix, Joe. You guys are all here. Yo, Kyle, even Kyle's here. Whoa, hey, what's going on? Hey, Kyle, hope you're doing good. Hope you're having a good Tuesday so far. All right, so Matt says you need to do regularization term over the output of the decoder. So it is going to be normal. Okay, so we need to do some sort of regularization. The mean squared and distance of the standard. Okay, so we can do some mean squared there. We can make that work. We sure can. All right, so where do we leave off here? On our forward. So I think what I need to do is figure out what our next forward element's going to be. Let's take a look at our reference again. So we got a reference file over here. Let me double check, make sure I've got everything looking good on this side as well. All right, perfect. Yes, right there. I have to give you time to miss me. Hey, Kyle, yeah, every now and then, right? Stop on by, give it a few days, come back, and they're like, oh, it's Kyle again. Where have you been? Okay, let's see here. I want my forward, right? Is there a forward here? Forward. There is a forward pass, and it goes encode, reparameterize, and decode. So we're in this phase right now. So let's get our encode going here. Result, self-encoder. We flatten it to get a result, and then we do some extra math to get some sort of MU and a log bar. Oh, and we return that. You know, we don't need to specifically put that into an encode. I suppose we could just do it just in a, a forward pass. Can you please make me a moderator? Mugafan, maybe you need to have, there's already enough moderators here. Rate the dog, cuteness, 1 to 100. How about 97? Is that good? Do you write code every day? I do. Radio, I do every single day. My RC car project's 100% complete. Nice. Get those projects complete. That's good to hear it. Good to hear it. All right, so we've got our forward. Our forward is our encoder. This is our forward here. We can do a flatten on the result in the dimensions to flatten it. Oh, because it's right. Okay, so what are the shapes of the output? So let's take a look at the shapes here really quick. So I want to log the shape here. So let's do a print ln explanation point. Is there a dot shape on the out, right? I can do a dot shape, right? So this is a forward encoder shape. This is what we want here. Forward encode shape. Yeah, it's a little bit of shaping on this. I want to see what this looks like. Out.shape. I'm pretty sure we can do that. I think maybe. Yes. Okay. We should be able to. Save that. All right. We got immediately an error. No, the first line of code, of course. You spam too much about 6 timeouts. Hey, see, Mugafan, you got to be within the right. You're going to send the YouTube community. Oh, well, you know what, Mugafan? I see what they're saying over there. You have to follow the rules and then set up a good, I don't know. What do you call it? When you do things over and over, right? Some sort of repetition. You need to show that you are a good community member first. I'm with Quick Fix on this one. All right, Bonzupi. See, hey, Mugafan. So maybe someday, if you follow the rules and you're good, then maybe moderator at that point. You posted a YouTube community. Oh, you did. Oh, right. Okay, let's check. I'll check one time. All right, Mugafan, are you ready? We're checking this one time. So Stephen LB, click on the community. All right, here we go. Oh, whoa, hey, this is the thing, 100% complete, you said. Isn't it cool? Finish on your house, really cool. Control with a watch and a remote. Nice. Very nice. The tires are very satisfying to see. Let's zoom in on that. The tires are very interesting. We got to see as a role model. Exactly the behavior that we want to see from the community, Bonzupi. Very nice. That's pretty clean. That's clean right there. The tires are very satisfying. I like that. Very nice. All right, line 63. Where are we here? Line 63. Why was that a problem? Oh, I know why. Because we need to say, oh, that. How about that? Nothing like that? No. Why not? Why not? Print ln this right here. Do we need to say 1? No, we say this. Right there. Shape doesn't implement. Oh, how about that? Hey, all right, there we go. All right, let's close this. We're gonna open up another window here. Cargo run. Many machine learning models needs large data sets. Karthik, there we go. It's the usual Karthik response. I need to see something better. Cat self-encoder. Here we go. Okay, so see, that's what the current shape is. Batch channels width and height. So if we flatten this, it should work better. Yo, Bimpa. All right, thanks, Steven. Bimpa, good to have you here. Welcome on in. Things actually control to the left and the right. Bandit doesn't turn. It turns when the rolling thingies. Okay, good to know. Yo, how's it going there? Colm? Hey, Colm SK20. Hi. Welcome on in. Happy Tuesday. Good to have you here. Okay, let's see here. So this is the shape that we were looking for. And if this is the case, then what I really need to do is I can do a flatten on that. So let flat. I think we can do, there might be a dot flat, right? Out dot flatten. Can we do that? That's something that we can do. Is that something? Nope. This method takes 2 arguments. 1, but 0 were supplied. All right. So what are the arguments that we need on that to flatten it? Do we need it to be this? Takes 2 arguments. 1 was supplied. What are the arguments? Yo, Rudra, good to see you. Welcome on in. Happy Tuesday. Good to have you here. Muga is in the crosshairs today. I know, right? Everyone, Muga is coming for you. Are datasets books and facts? Yes, that counts as dataset right there. That's a dataset. Also prefer if mods are also people who are hands-on with projects. That's a good thing. That's a good thing. It shows that you've got ambition. It shows you got ambition. All right, so how do we do a flatten on this, yeah? Let me see here. Flat. Do we have a flat? Do we have a flat? I suppose we could do a resize. Let's see here. Let me see if there is a Google Candle Rust flatten tensor. See if we got some answers here. See if we get some quick answers. There's a flatten to, a flatten from, start dimension. Okay. Yo, Joel Jose. Oh, Joel Jose. Hey, thank you for subscribing. You joined the right channel for software engineering. Good to have you here. Happy Tuesday. Let's check the documentation for the flatten. Yes, let's do it. We're checking it out. So 1, 2, flatten dimensions from index 1 to 2. Shape becomes 2 to 12. And there's also flatten from, completely flatten the entire tensor into 1D shape, becomes 24. This is what I think I want right here. I want the flatten from right there. Hayden Hill, good to see you. Welcome on in. Happy Tuesday. We're continuing our variational autoencoder today. All right. Hello from Thailand. Hey, Colms. Good to have you here. Welcome on in. Let's see. So we can do a flatten from, because that's easy. From May, a little bit of from there. And then do we want to do flatten from 1? I think so. Here we go. Let's do a print ln on the flat to make sure that we got the right shape. This will be the flat shape. Flat. All right. Then I want to find where the other print line is and hide that because it's a little bit too much. This one here, hide that. We don't need that. Well, nah, that's, yeah, just do that. Okay. Where's the other print at? Here we go. We want to hide that. There we go. 1, you're afraid of Rust. Hey, Kyle, it's a really good programming language. That is a systems level programming language. Really good for performance. Yo, me, Siva, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. Good to have you. We are building a variational autoencoder today. This is going to allow us to make a pretty picture of a cat. We're going to make a pretty picture of a cat right there. And we are going to try our best. It's sort of a step towards stable diffusion. Neva helped us get started on this. And we have a reference Python file written in PyTorch, and we're converting it to Rust in Candle library. It's a Hugging Face library that was inspired by PyTorch. Git's the greatest tool for version control. I agree with you. It's been the #1 best so far. Designed for managing contributions to the Linux kernel. And so you know it's good. Yo, the King Vokara. Welcome on in. You joined the right channel for software engineering. Good to have you here. We are building our variational autoencoder today. Ambition of a coder. There you go. I'm with you that. The never looks like. Muga what? Muga what? All right, let's see here. Let me run that real quick. No, wait, not that one. I want to run over here. My cargo build. Here we go. All right. There. That's what I think we need right there. So this gives us every single color and pixel in a flat format. Now I can use this in a linear a linear input. And the input of the linear model needs to match this value right here. So is that the correct size? Is that the correct shape? So we have something else up here called this FCMU and the VAR, which is what we're currently going to calculate. Machine learning needs large data sets. Karthik, hey, with the OG. I remember, Karthik, you like to say those things. The day set of the diagonals. Hey, Diagnosis, phenomenal, supercalifragilisticexpialidocious. There you go. Rust, hey, yeah, Combs, this is Rust. We're doing Rust right now. You got it right there. A little bit of Rust. Dog the QC score of 1. I time out, yeah. You have the opportunity to do it. All right, so I need to see what the output format of this is here. I need to see what the shape for the FCM is. This is going to be flatten. I need to see the flatten. Let's see here. Then, no, /flat. Yes, thank you. This is what I need. I need to see the output shape for our self dot, this FCMU dot shape. I need that right there. Yo, Kyle with the 6-7. Thank you very much, and my gratitude to you, Kyle. That was awesome, unexpected. I see there's such a weird. Why is that a donation thing? Why is it a donation? Oh, Kyle with the hiding. Thank you for the hiding and for the 6-7. These are very strange, right? The hiding in 6-7 of the kinds of donations that can occur. Hey, and 2 more hidings. Yo, Kyle, thank you. Can we teach a machine to learn how to create decks? Yes. Sergey, you can teach a machine to do anything. Yo, Kyle, for the 4th hiding. Thank you. Oh, my goodness. You're so wonderful, Kyle. Thank you very much. Appreciate it. That was unexpected. Oh, wait. There's another one. You stacked them up. You put so many in that you had the notification stack. Cheers, Kyle. Thank you. Thank you very much. Kyle, appreciate it. All right, we need... Oh, Kyle, that was awesome. That was unexpected. All right, here we go. So the FC... I need to see what this is. I need to see what shape that is really quick. So it's got to match the right shape. So we need our flat and we need our FCMU. We need to grab this here. Okay. And then we're going to see what this looks like. Save that. Oh, we got an error. Okay. Shape for struct handle linear. Oh, we can't get a shape for a linear? Okay, so how do we get the shape of a linear layer? Google Rust candle shape of tensor. How do we grab that? I thought it would just be dot shape. See, it says dot shape right there. Right there. Oh, come on. It's a linear layer. Oh, it's not a, oh, sorry. It's got to be a linear layer. So that's what we need. All right. So would the data set all be the cards plus the rules? Can we teach machines to learn how to create decks? Actually, yes. And at that point, though, Sergio, it really depends, because are we building like a card game here? In that case, it would you just want, I don't know if you need AI for that. You just need an RNG. You need to see random number generator. Just some RNG there. All right, how do we get the shape here for the linear layer? Yeah, how do we do that? I want an example. Tensor dimensions, bias. I need the width and the size of it. I need to see how many units. Batch shape. How do we get it? How do we get the shape? I already know we know what the answer is because we've defined it. So where is this at here? Let's go up here. It's going to be hidden and latent. So is that going to work? Is our hidden big enough? I don't think it is. AI offline. They were given to me on YouTube with the emojis. Oh, they're chosen because of the free gift budget. Whoa! Oh, I didn't know about that. Nice. Hey, Ice Rainbow, welcome on in. Krishna, hey, good to see you. AI, online AI. Online. Remove the timeout. All right, sounds good. Does anyone use digital DJ decks? Put some software together called FreeJ. People can DJ with free, paid-for features unlocked. Yo, Joe, excellent. How's it going there, Mr. Psychedelic 9595? Good to see you. Welcome on in. Happy Tuesday. Use Claude Code, bro. I know. That's the way to do it. I do use Claude Code. And you know what? We would finish this immediately if we did. However, we wouldn't learn anything. I want to learn. So I'm going to do everything with my hands on my keyboard. Krishna, super. Excellent. All right. Let's see. So this is going to be my hidden latent. What is my hidden latent set to? Let's find out here. Okay, so I've got my answers here. It's going to be 32 and 64. Is that enough? I don't think so. I feel like that's not the correct answer. Hidden small. Okay. We need the shape to change here to make this work properly. So I'm wondering if we need to change this up. We might need to change it up. Okay. Hey, Neon Java, welcome on in. 9 like, Krishna, thank you. Happy Tuesday, Neon Java. You spend $200 for a month for the Cloud Code, but you still write code every day? You do? Nice. Hey, all right. Hey, there you go. Very nice. Good to hear it. All right, let's see here. All right, we need to get the output. So I already know what the shape is. It would just be really nice if the linear layer would have like sort of a shape of somewhere. I know it would be really nice. It would be so satisfying if it did. Okay. Bimpa. Hey, Bimpa. Yo, what's going there? Shaikh Umar. Yo, Shaikh Umar. Yes. Good to see you. Welcome on in. Happy Tuesday. All good. WBU, happy Tuesday. Thank you. All right, we need to get this layer right here work better. This layer work better. It needs to work better there. And do we have a hidden? Do we need to specify the hidden? Is this something that we need extra somewhere else? Let me see here. Let's open up our reference really quick. By reference. And we're almost at the point where we don't need the reference so much. All right, I need it to be the FCMU. This is what I'm looking for right here. All right, /FCMU. Here we go. All right, where are we here? Linear. It says hidden. Oh, hidden and latent. So it's got big. Okay. So it's big to small. Right, the latent, right? On the latent output. Okay. So latent is small, hidden is big. Coding, decoding. Yeah, that's what we're exactly. Coding, decoding. Got it. Bro, you look like a famous scientist in NASA called Miriam Mirza Kahani? Who is that? Let's see here. Let's find out. Google. We say Miriam Mirza Kahani. All right. Let's find out. Let's see. Yo, what? No way. You think so? Well, I guess we got big hair or something. I don't know. Maybe not. I don't know. Miriam Mizarakani. All right. Well, thank you for saying. Do you got a dog? I do not. Let's see. Hello. How's it going there, Hassan? Welcome on in. Who's Miriam Mirzakani? Apparently a NASA scientist. There's a slight resemblance. It's just a slight, yeah? Hey, Hassan, hello. Welcome on in. All right, let's see here. Let's keep going. I am interested in figuring this out here. I'm going to see what's going on here. Okay, let's see. So all I need to do is get this layer specifically to give me an output. Oh wait, so we're flattening it here, right? Right, because we need to convert it into starting dimensions 1, right? So that's what we did. We did a flatten 1. And then I need it to get the right shape so we can throw it through the feed forward on this. So the input shape, it's a 1. What would that even look like? All right, let's see over here. Let's find out. Why Subway Surfer is an endless game? Is it really? It's an endless game? It never ends? I did not know. Bro, you butchered that name, but subtitles kept up. Yo, Joe, really? That's great. Miriam. All right. Connie? No, not quite, right? Here we go. All right, explored Hugging Face. It's some trained AI. Yes. They exactly trained it like it's cool. Yeah, there's a whole bunch of open models over on Hugging Face. Which terminal are you using? I'm using Ghosty. This is Ghosty. Ghosty terminal emulator with Tmux and Vim. All right. Here we go. FCM linear. I need to change this. This needs to be the right shape. So if it's 100, if it's 1 by 3, like a really big number. All right, where to see your shape? We don't need this to do this. Let's hide that. Save it. Wait. No, this one here. There we go. Let's close this. Rerun cargo really quick. See, I need it to be the right shape. You try to learn Rust, but it's killing your brain cells, and you just have to give up. Don't worry, it does that. It does that, and then you come back to it later once your brain cells has recovered. Right? Once you've recovered your brain cells, you can go back to it later. You look like you could play Spider-Man. Oh wait, let's see, Tom Holland, right? Tom Holland, Spider-Man. Yo, how's it going there? Gone 3302. Hello, Stephen Blum, who played Spike Spiegel. Spike Spiegel. Wait, Spike Spiegel? Wait, hold on one second. Google Spike Spiegel. Spiegel. How about? Let's see this. Oh wait, that might be a different Stephen Blum. I see what you're saying over there. The voice actor. Yeah, the voice actor. There is a voice actor that plays this. I am not. This is a different Stephen Blum. We look very different. It's a very different Stephen Blum. Very different. Thank you for pulling that up, though. Here we go. So, how do we do this now? I want my flat to be able to push that forward. Let's see. Do self.fcmu.forward on our flat. Here we go. Our FC, let FC underscore mu equals. All right, let's try that. Wait, why is a mismatch types? What for? What for? Let's see, did I get this correct? Yes, it looks good. Flat, looks good there. Okay. Does it want a address? How about that? There we go. Much better, much better. Every time I'm on YouTube, you're live. Hey, is there any challenge you're doing, like 100 days challenge? Actually, I don't know. I don't know. 100 days challenge, that sounds like a lot. We're just streaming every day that we are available. 3 Lestand damned. Oh, hello, Elliot Page. Hey, welcome on in, 3 Lestand. Good to see you. Happy Tuesday. Hope you're doing good. All right. Let's see here. Elliot Page. Google Elliot Page. Let's see here. Oh, right. Someone was mentioning this yesterday. You guys are funny. All right. Let's see here. All right. Cargo run. See, it should fail. Error mismatch. Yes, that's what I thought. Okay. So a 64 by 32 is not the same as a 368 by... So we need to get our hidden to be the size of that. So we need a 3 by 34 by 34 to be our hidden. So let's see, /hidden. We're going to change this instead of defining that and defining our latent. We're just going to create it. We're gonna create it here. All right. So we need to define our let hidden equals our pixels times 3 color channels, and then our latent needs to be smaller. So I suppose we could just do pixels times pixels, maybe? Something easy? Something simple and clean like that? Yo, Jinlu, good to see you. Welcome on in. Happy Tuesday. Good to have you here. Hope you're doing good so far. Going to the win. Hey, yo, Baby's here. Good to see you going to the win. Welcome on in. Happy Tuesday. Good to have you here. Is there a Jeff back again? What does that mean? Yo, Polarize. Hey, Polarize. What is that? Good to see you. Welcome on in as well. All right, let's see. I think we need our hidden and our latent. Then I need to update our VAE, and we don't need these. We still need the pixels, though. We still need the pixels. So we're going to eliminate that. And I suppose we could do a divide by 2. So, wow, that worked immediately. Okay, here we go. VAE, implement new. All right, I'm going to close this for a second so we can read through this a little bit more easily. So let's see here, hidden and latent. Yes, so that drops that down, and I believe that should probably be fine because that's going to be the output. Then we also have an FC var, which I don't know how to use yet. You got to create another beat. Oh yeah, Jinlu. Absolutely. Hey bro, you're creating an app or something? Surav, yes, we are building a variational autoencoder, which is going to give us a picture of a cat. We're going to try to draw a picture of a cat. Right there. A little bit of picture of a cat right there. Same terminal. Oh, you do? Hey, Harsh, nice. Ghosty for the win. You want to blur the background in NeoVim. Enter full screen mod, F11. The terminal is not supported. Oh no. Oh, got it. Okay. Yeah, I remember doing that back in the day. I remember doing that. What are we doing today? Going to the wind? We're going to continue the variational autoencoder, which is going to take us a little while. It's going to take us a while to get, and we're going to make a picture of the cat. We're going to use the cat as the input. We're going to get random Gaussian blur for a like noise, Gaussian noise. And then we're going to train the AI to render the cat. That's what we're doing. Yo, Yogi Bear, good to see you. Gang, why don't you have a robot yet? Ooh, maybe someday. I'm waiting for the good robot. Hey, Harry, good to see you. Welcome on in. Happy Tuesday. Machine needs large data sets. Karthik A with the common regular Karthik. I love it. You downgraded an iPhone? Wait, Jinlu, really? Yo, Cyberlanka. Hey there, Mr. High Energy. Good to see you. Welcome on in. Happy Tuesday. Render hamsters instead? We could. I just have a picture of a cat. I mean, all we have to do is find a picture of a hamster, and we can do that. And then we're going to build some more other fun things after that. Hey, Barry. Good to see you, Barry Rex. 2960. Welcome on in. Did no one watch Terminator? Yes, we did watch Terminator. We know Skynet is going to be born, and we can't stop it. Remember, you've seen the movies. You could never stop it. It was never meant to be stopped. We're waiting for your robot. Someday we'll make it in. Yeah, Pixel looks good there. Okay, load image forward, and then I've got my latent and my hidden. All right, so I think this should be fine. Let's just hide that right there. We'll go like this so it looks a little better. And then we got a resolution, which it's the same as hidden. So we don't really need resolution. Hold on, are we even using it? We're not even using resolution. Let's just delete that, yo. Delete that. It's just wasted. It's wasted. Yes, but the older model Terminator is the good one, right? What was it, right? There was the good one. Arnold Schwarzenegger. Yo, how's it going there? SD Bibble for you. Welcome on in. Good to see. Hello. I'm trying to say your name. Your name is challenging for me to pronounce. Let me see if I get it and everything. Uktum. Hey, Uktum. Good to see you. Welcome on in. Yo, Abdul Aziz. Thank you. Hey, Abdul Aziz. Thank you for subscribing. You joined the right channel for software engineering. We're currently building a variational autoencoder today. Good to have you here. It's going to be a long multi-day project. Some of the images on your phone in general chat. Oh, hey, I want to see. So waiting for the good one equals failure. Yogi Bear? Yes. Oh, right. Good point. So we need the first one. You're saying we need the first one because the later ones are the bad guys. I see what you're saying. How much pixels are you talking about? 32 by 32. So that is a very small picture. We're doing a very small picture. Let's check out Jinlu's picture here. Yo, wait, that's not an iPhone. Oh, your phone is a Pixel though. Oh, hey, Pixel. I'm looking to get a Pixel. Oh, this is the iPhone you're talking about. Here we go. Yo, I had this phone. This is one of the phones I've had. I had this phone. Here we go. I had this right here. I remember this phone. And it had this old connector. I remember that. Yo. That's a blast from the past right there. Yep. Check that out. Cool. Yeah, I played so much games on that phone. Oh, I played so many games. Very nice. It's cool to see that. Very, very, very nice. All right, so we got our hidden, our latent, our forward. Let me do this real quick. Run. I believe it's still a problem, right? It's going to give us an error. Yo, that is very weird. That should have handled immediately. Error type mismatch. Okay, so let me try that again. Let's run that again. Should have been instant. That is taking way too long. That is taking way, way, way too long. It should be like, boom, instant. All right, mismatch 1 by 3468 versus 372 down to 1024. Okay, so I believe my hidden and latent are way too big. So I probably need to drop those down. Yes, okay, I got it. My latent needs to be a lot smaller. So let's just turn it down to a 32. All right, let's try that. Let's make that a lot smaller. There we go. That's a lot better. Yo, Neva, good to see ya. Welcome on in. Happy Tuesday. Good to have you here. We're very slowly working through the variational autoencoder. We're going to make it work. We're going to make it work. I'm getting every piece in the right spot. Do you think the latest iPhones have huge differences? Yes, they do. They're definitely more powerful, and they are not slowed down by the operating system intentionally. iPhones are useless. Are they? I thought they were fine. I have an Android though. I do have an Android. I like my Androids best. I like them. All right, so we got our hidden and our latent. Our hidden needs to be bigger. So why is the forward a 3468 and our hidden is 3072? What is missing? That's very weird. We need, oh, interesting. Okay. So how do we get this number? How do we get this number? You downgraded to the iPhone because it was really slow on iOS 9? Yeah, it's, I remember having to do that. Yo, Mean Parakeet, good to see you. How are you, Steven? Sorry, I'm late. Hey, welcome on in. Good to have you here. We're doing good. You're not late at all. Yo, Zeus. Hey, Zeus, good to see you. Welcome on in. Hope you're doing good over there. Someone in a character solved the hunting problem? What is the hunting problem? You choose Android every day? Me too. I'm using Android going forward. I am. Except for I'm definitely running a Mac here. I'm running a Mac operating system from a compute standpoint. All right, where are we here? So our latent looks better now. We're good on the latent. What would be nice is if we could figure out what we need here when we flatten this. We need the inputs to match here. So how do we do that? What is this? It should be this. 34? Oh, okay, hold on a second. Wait. No, it's not 32, it needs to be 34, that's why. Okay, that describes that. I just need to see what, maybe our config needs to, do I need a stride or something? Stride 1, something like this. I think the padding 2 should, maybe I do a stride 2. Let's double check here. Let's try this again. No. Here, I need something different. So let's try padding. Let's do a stride 2. Stride 2, padding 2. Let's try that. Let's see what we got. We need it to convolute more. 17 by 17. Okay, see, now we're making a change there. Now we're making a change. You're the only solution is to just don't? Is it the only? The number is the multiplication of the row and column. Yes. That's it right there. It sure is. And what we're doing is I'm trying to control it through the ConvNet. The ConvNet is going to reduce. It's going to find, it's going to stride. However we roll over our projections on the input image is how I need to change this up. So stride 2, padding 2. I need to figure out, maybe do padding 1. Let's try this. Padding 1, stride 2. See if that works better. 16A. Okay, see now it's an even number. Now we can make it work. Now we can make that work. So we just need to divide by 2 on our resolution, on our hidden. So we're going to say half. Let half equals a, let me say, pixels divided by 2. Just do half right there. All right, like this. Copy this, and we'll do half on the latent, half on the hidden. And then we will make sure that works a lot better. There we go. That's it right there. All right, we got second layer. Good to go. Max pool does nonlinearity. Oh, we need to do max pool is what we're saying. You can add a stride, but you can also add max pool. So we should probably do max pool instead. Okay, I'll do max pool instead. Hey, let's go in there. I think nothing 1, 2, 3, 4. Welcome on in. Happy Tuesday. Did you start your coding journey by making a calculator of Hello World? I made my first program was a C in, C out. If you remember this, the ins and outs with the arrows in C++. That's what I did. Yo, how's it going there, Smart Live? Welcome on in. Alone on the road when I reach your home and his squad pulling up to your next extreme. Add me on your Discord username. Oh, okay. How's it going there, Smart Live? Hi. Welcome on in. Happy Tuesday. Okay. I am interested in continuing this. So we got that working. Now, instead though, would we want to do a max pool? Let's get a max pool going. Let's get our max pool going. How do we do that? All right, let's do Rust candle lib max pool. See how we grab that. Google, a little bit of Googling here. Smidgen of Google. Yo, how's it going there? HJFG1. How's it going? Good to have you here. Oh, we just say .max pool. Oh, that's easy. Oh, that is so much easier, isn't it? Okay, that is so great. .max pool right there. And then we say what we're looking for. All right, so that means that we don't need to define it there. We can just do this on the forward, which are gonna be much better. So much better. All right, yo, Random. Thank you for subscribing. You joined the right channel for software engineering. Good to have you here. Happy Tuesday. Harry, to everyone that likes curry, Indonesian curries are superior. They're pretty good. Yo, Wing Wong. Hey, good to see you. Welcome on in. We're continuing our variational autoencoder. We're making it work to draw a picture of a cat. That's what we're gonna do. We're gonna draw a picture of the cat. We're gonna make it draw a picture of the cat. All right, let's see here. And we want our output here to go with a max pool on the output. So let's see if we can do that. Let's see, all right, let's do let pooled equals out dot max pool, right? Was it a max pool with an underscore? Yes, 2D, max pool, 2 dimensions, 2, question mark, probably a question mark. They always a tensor with a question mark, right? Yeah. All right, let me double check. Yeah, okay, good. All right, so max pooled. All right, I'm gonna print out the pooled. Let's print it out. Print out our pooled here. There we go. All right, I wanna see what this looks like. Run. All right, what's our pool look like? There it is right there. Okay. So that dropped it down to 8 by 8. So we could do a divide by 4 if we wanted. Or we could increase it, right? Because we want more hidden layer. We want more hidden units. And we want fewer latent layers. Yo, Cosmic Whale, thank you for subscribing. You joined the right channel for software engineering. Good to have you here. Happy Tuesday. Go lift a heavy rock. Hey, a whole bunch of X's. Mark Lemon, happy Tuesday, brother. Good to see ya. Welcome on in. You guys are awesome. I'm so glad you're here today. Let's see here. So we're making our way. We're making things happen. Do you have a favorite ML pattern? Yes, I do. I do have a favorite ML pattern. Let's see. What is my favorite? My favorite ML pattern. One that is. So the support vector machine, which is right on the tail of linear regression, allows you to add extra dimensions. And just in general, deep learning, where you stack layers, multi-layer perceptron with an activation function for nonlinearity. That just pattern in general is the foundation of most AI and machine learning. So I really like that. Yo, how's it going there? Sir Davo. Oh, wait. Okay, I see what you said there. 1 second. You're one of those things. Boom. Okay. All right. Do you have FPGAs? Oh, field programmable gate arrays. Hey, easy. I know what you're saying over there. Some FPGAs, field programmable gate arrays. Let's see. Let's get our pool going. So if we're going to do a pool here, that means our hidden needs to be divided by 4 and not by 2. Our half will be divided by 4. Okay, let's try that. And can we do a forward on this? We did. We can do a forward here on our flat. Is our flat good enough though? See, let me see. Let me print this out. Print this, our FCMU. I want to see what our shape is going to be here for this. Looking good. Okay, let's run this and see what we got. Mismatch. I figured it was a mismatch. Okay, so it wants 192 versus 768. Okay, so this is what our flat looks like, and then our 192. This doesn't look correct here. So what is our? Does it say RHS? Let's see. This. So our flat definitely. So that means the MCU needs to be different. Right here. Okay. Hidden to latent. So is hidden really 192? That doesn't seem quite right. Because our flatten goes to 177.68. Okay. So I need to fix this. Oh, okay, I see. So I need to change this. All right, to mine times 4. Well, because 192, on calculator. Let's see. Times 4. 768. There we go. All right. Perfect. Does the 3 in the self encoder tell us about the color? Red, green, blue. Yes, it does. You're absolutely right. Layers, trees, graphs, loops, attention, embedding, space, convolutions are the ones you're looking at. Hey, very nice. Embedding is a very satisfying pattern. It's very satisfying. It's straightforward. It's simple. It's seamless. I like it. 3 by 8 by 8 equals 192. Yep, that's it right there. We did the math. You got the math. That's it. This number right here. You got it, Bimpa. You're welcome, Sergio. All right, let's keep going, you guys. It's possible that we can make our next step. We can make our next forward here. We can make it now. All right. We'll run this. Forward. Success. Right there. The FCMU looks good. Okay. So how do we do by reference? What do we need next here? So we got the latent. Very interesting. That just happened to be what we chose. Okay. Linear, hidden. Yep, looks good there. Is this... Are there 2 here? Oh, here we go. Okay. And then we need a log var, which is our FC var on the output for the result as well. Okay, so it's the same thing. We do 2 at once. And this is the encode, but it's only returning the MU and the var. That's weird. Oh, weird. Okay. So we don't actually return the output from our encoder convnet. We only return the MU and the var here. Interesting. All right. Are coding that fun? Mean H. Yep, Mean H. Mean, good to see you. Welcome on in. Yes, we are. We're making fun here. Welcome back, Quick Fix. Let's see. So where do we reparameterize? When do we run this? I know I see the MU and the log var here. So we do some reparameterization here. So we do our encode and reparameterize. All right, so this is the step that we're on right now. We're on this step right here. So we need to do this part. Hey, Adnan, good to see you, Adnan. I'm trying to get your name to show up here on the subtitles. Welcome on in. Status of what? Okay, let's see. So I've got this. This looks good. So that's going to give us the outputs from our FC, and we need to do the same thing for the other one here. So let's grab this here. So we're going to do our FC underscore var, right? Grab this over here, forward. So we got our var. I'm going to grab this. It's going to be identical. It's going to be the identical as the one above, basically, right? It's basically like 2 additional projections. Okay. Rerun that real quick. And then we need, oh wait, what's this? Okay, so we'll need to do this next. I'm not exactly sure what this step is, but I see epsilon, standard, and MU there. A little bit of extra stuff there. And then our forward is going to return our input, our MU, and a log and a decode. For whatever reason, I do not know why. Yo, Destructive Lotus, good to see you. We want tutorials, Blum. Hey, which ones? Which ones are you looking for? Right now, we're doing the variational autoencoder, and I am only getting familiar with it myself. Hey, I was going there, Cactile. Hey, Cactile. Good to see you. Welcome on in. This is not pre-recorded. Good to have you here. Cactile. Welcome on in. Happy Tuesday. All right. Cactile. Where are we doing? My bro turned down Samsung money just to create chip. Wait, really? No way! That's a bold move. That is a bold move. What are the chances of doing a game jam? Oh, hey! We've done one of those. I would be down to help organize if you're open to it. Yeah, someday. That could be something that we do, yeah. STD is the standard deviation. Thank you, Bimpa. STD right here. STD right there. Right there. A little bit of standard deviation. Right? Torch, EXP, log var. So is that how you do a standard deviation right there? Let's see here. A standard. All right. Looking good, looking good. So this means that we're going to have to do a little bit of extra math in a different format. You have such a good auto captions. It is good. Yeah, this auto captions that we built many years ago. If you're interested, you can grab them too. You sure could. Thank you, thank you. I want to be an AI engineer, Mr. Blum, and I'm very interested in this. Oh, excellent. Well, you start off with linear regression, which is the precursor. It's the beginning. You could use something like scikit-learn. I like this. Scikit-learn is a good starting point because it lets you easily just call upon predefined functions. And if you want, you can build your own learning neural network. You can build your own learning neural network. Hey, Quick Fix, thank you for the link. This is for our auto captions here. If you want them, you can grab them. They're available to you for free forever. Free forever. Why are doing standard deviation? I don't know. I don't know. I'm not. This is just part of the tutorial that we're grabbing, which is a PyTorch. This is a PyTorch tutorial, and we're converting it over to Rust. So I do not know. You're learning Python right now. Hey, there we go. Python. That is the correct language to learn, I think. Yo, username 18. Thank you for the sparkles. My gratitudes to you. Good to have you here. Happy. Thank you very much. CS50. Nice. That is really excellent. You are on the right track. You are on the right track. Keep going. Keep going. Minecraft music, please. Do I still have Minecraft music here? I don't have the Minecraft music anymore. I don't have it anymore. It's gone. If you find the link, maybe I can bring it back. The Creative Commons one, right? You think Java better than Python? No! Al Noob! Wait, no. Alan Noob? Nope. Java is not better in multiple reasons. It is very, very expensive. It is wasteful. And it's only good if you're running it locally as a single app. If you're running it as a production infrastructure, it is so expensive. It is just, we're dumping buckets and buckets of money into these Java systems that we're running out of my company right now. And it is just the worst. It is the worst. I do not recommend it. For anything that's needed for performance, I don't recommend it. You don't have any, what font do you use? This font here is called JetBrains Mono. It's called JetBrains Mono. JetBrains Mono. The company is PubNub. That's the company. Company equals PubNub. This is my company right here, you guys. Good to have you here. For those of you who are new, my name is Stephen Blum. I am the CTO co-founder at PubNub. We raised 134 million, Series E, 1 billion devices on my network today, a lot of patents, and I've been in tech for 25 years, professionally. Don't get Steven started on Java. I know. See, I've got proof. I've got proof. Thank you so much. Hey, absolutely, Cactile. You got it. Rust is better than Python? Yes, Rust is better as a systems language. It is a lot more work from an engineering perspective because the compiler is very strict, because it has parallelism safety, concurrency safety, and memory safety all at compile time, which you don't need to worry about in Python. So Python's a lot more approachable. But too verbose, right? See, that's also another reason. Java is too verbose. It is way too verbose, and programming in it is not satisfying because of how much extra keystrokes you have to do. I'm with you on that. I am completely with you on that. Okay, so we got our FC and the FC var and MU. So we know everything's going on there. That's good. So now we need to do a little bit of math on this really quick. All right, so our forward, we got our MU and var on our encode. And then we need to do our Z to get our reparameterize. And then we return a whole bunch of things here. A whole bunch of things on the forward. We need to define decode separately. So let's do the reparameterize here. So just the mu and log var. So we need std and epsilon, which is weird. Random like. This is odd. So that's not. You can't create gradients from that. Do we need to do this? I think we can probably skip that step here. Let me see here. Let me grab this. All right. 1 second. Right now I'm learning Node.js. Yo, on the right path. Yes. Elnon, that's also very common. JavaScript, TypeScript are very common industry programming languages. Very, very, very common. Yo, Kyle, there we go. The correct symbols. Nice. Those are the correct symbols right there. All right. Let me see where we're going next here. You're refraining on Java? All right, but I think garbage collection is bad. It is. It can be very rough. It can be very rough. It certainly can. Nice. All right, let me see here. 1 second. Mu forward log var. Okay. I'm just going to look at some latent reparameterize. Okay. All right, so let's go ahead and create a function called function for reparam it's all right. And self, we need the FC and the, what do you call this? We need a couple of things. The mu and the var, the FCMU and the FC var. I think that's it. I think that's all we need. And these are going to be our tensors. These will be and tensor. Another and tensor over here. There we go. There we go. Send the link. Yo, Krish Ice. Hello. HLO. Good to see you. Hey, Lily Love Snow. Good to see you. Hi, did you miss me? I sure did, Lily. Good to have you back. Welcome on in. Happy Tuesday. You just want to know, is words per minute matter at coding? No, it doesn't. Because I got friend that coding have 20 words per minute. Coding, you do very little typing in coding, right? So like right now I'm kind of reading code and then I'm writing a few lines of code, and I don't need to type very fast because that's only about 10% of your time as a software engineer. You're actually writing code. The rest of the time you're trying to solve problems and understand where things are broken or needs fixed or how to upgrade a service. So it's a lot of thinking and very little typing. We don't miss anyone here. You're free to come, Steven. Is it forced? Well, it's so good to have you guys here. Okay, Alnon, sounds good. It was good to have you here. Thank you for hanging out with us. Where are we next here? Results, tensor probably, right? Tensor. Grab a tensor here. I'm pretty sure we're going to return a tensor. Or maybe more than one, right? Because we're reparameterizing it. Let's see here. No, just one tensor probably. That's why. Hey, yep, there we go. You got it right. I'm in your friend's house. My friend is not here, like what? Oh, well, that's unfortunate. Okay, remember me. I will be back tomorrow. Sounds good. Alan Noob, we'll see you tomorrow. Have a good rest of your day. I'm gonna stay right here, and I'm gonna program my reparameterize function here. We're gonna convert it to Rust. Where are we at here? So I need to make this into Rust format here. Okay. So that'll give us an error immediately because line 63, we don't actually return anything yet. Okay. So let me see here. I need a standard to equal something, and I need an epsilon to equal something. And then we're going to return some sort of output. Let output equals. Okay, we need that. You're glitching? Wait, Lily Love Snow, you're glitching? Uh-oh. Hello, 8382, welcome on in. You should make XGPT and Grok AI play each other in Uno. Hey, we could do that. I know how to do that. We've done it before. We had chess. We did the chess battle with ChatGPT and Gemini. We could have them play Uno as well. Looks like a Nintendo game? Yeah, it's because I got build errors. I got build failure. I got errors. I got to fix them. Got to fix my errors, you guys. Okay, so I need to do this part here. I need to convert that right there, the standard. Let's see here. So we can do, what is this called? My FC var. So we'll do our FC var. And we need to multiply that by 0.5. Right? I suppose we could do it this way. 0.5 times. So it looks the same. And then we need to do an exponent on that, right? Which in Candle, it's all this, I think, right? I think that's the way it looks right there. Here it is. Good. Wait, what? Letters must be pronounced apart. GGGOODDD. I see no glitches. All right, good to hear it. Good to hear it. Let me hide this. Is this a tensor? No, I don't know if that's going to be... It probably is a tensor. All right, so, okay, STD. Let's see if that... No errors? We still have an error at 64. So this is broken. No method named exp found on enum results. Well, I can tell you that we have to change that. We probably got to put a question mark right here. There we go, making our way. Your iPhone stopping and playing like please. Oh, your iPhone. Well, I hope your iPhone works. Oh, GoGo. Hey, GoGo. Make a pixel RPG Final Fantasy type game. Love to see that. Yeah. Make 2 AI programs fight each other in a boxing game. GoGo. All right. So you guys are talking about this, and it's very interesting because this is something that we've been talking about at PubNub right now. We might do that. We might do it. Hey, Fantastical. It's good to see you. Welcome on in. Happy Tuesday. Did you see that snippet I posted in Journal this morning from Zuckerberg? I thought it was well said. Let's find out. Let's find out. You said in general from Kyle this morning. Kyle. Oh, let's see. Most other labs focus on building AI for companies, governments, or other institutions. So if those labs lead, then the balance of power will favor larger institutions over the individuals. Meta's mission since our founding has focused on putting power into the people's hands. If our belief and principles lead, then the balance of power will favor individuals, better for the future for everyone. Well, that is very nice to say. Let's see how it happens. Yo, CAO, good to see ya. Welcome on in. Fighting the AI's AI contests like we used to do with Robot Wars. Yes. Hey, GoGo, are you someone else? You're saying interesting things. I recognize what you're saying over there. I recognize what you're saying. Okay. Yeah, I've heard it. I've heard it before. All right, so now we need to do our epsilon. Our epsilon is going to be a new tensor that's going to be like. So we need to do a rand like. I don't know how to do that in Candle Library. So let's do this. Google rand like in Rust Candle lib. How do we do that? Let's find out. Bro, please work Wi-Fi. What? I know, right? Make the Wi-Fi work, please. Reparameterization trick. Can you tell me about that? Yo, tell me more. Cole MSK 20. Tell me what that is. I don't know what that is. All right. So input tensor.rand like mean standard. Oh, method signature. Original rand like. Oh, hey, look at that. That's so much better. Oh, we could do that. Okay, so we just grab this. Oh, that's so good. Okay, so our epsilon is going to be our standard deviation to rand in like 0.021. And then we just put a question mark on it like that. Good. Yeah, look at that. Oh, so clean. So clean. All right. Almost done. So now we need to just do a multiplication on all of these guys. So I think we can just do a little bit of simple math. Okay, so let's do out. I need to do ESP times STD. So ESP times STD, question mark. And then we do another out. And then we say out plus MU. I think we have to, since it's a tensor operation, we have to throw another question mark around that. And we say out. All right, there, reparameterization complete. Oh no, I've got an error. Oh, right. My variable names are different. This would be FC_MU. How about that? All right, ESP should be fine right there. That should be fine. Yo, what's wrong? All right, we'll figure it out. We'll make it work. Please, anyone hack VTU exam question paper. If you think smart in hacking, I challenge you to public them. Yo, that sounds like a challenge right there. Did I just hear 2 AIs fighting each other? Yes, you did, Joe. Currently what I'm working on right now, you are? Hence, oh, got it. Okay, it makes sense now. Robot Wars in the UK was massive. Yeah, it was. Hey, CC, good to see you. What programming language is this? This is Rust. This is the Rust programming language. It is a systems level programming language intended for extreme performance and reliability. We're using it to build AI to draw a picture of a cat. Two things won't compile: typos in the variable names, missing question marks on the zero cell calls. Oh, nice. Yeah, I'm excited about it. So we need to figure this out here. 1 second. Going to try this. All right. So ESP is not found in the scope. Oh, yep. You saw it right there. All right. So this is epsilon EPS, not ESP. There we go. Thank you. Please hack the exam. Oh, you don't want to hack the exam. Just geek on the net. Just geeking on the net. AI contests. We could do it. You wish you could download the guys on computers programming skills? You wish you could download this guy's programming computer skills. It is a thing that can happen. Oh, I am with you. Okay, so I think our reparameterization is done. Did we do it? I think we did. We converted it successfully to candle. Now we can do on our forward. We need to grab our forward here. And then I need to return more things here. I need to return more things. Like the Matrix, right? You just plug in and then it downloads all the skills that you need. Now you know Kung Fu. You know Kung Fu now. I want to watch that movie again and just like watch it. How not working, bro? Low Wi-Fi? What's wrong? Oh, I don't know. Lily loves snow. Oh, that's terrible. I hope it works out. Let me see. Okay, we got 17 minutes, you guys. We've got 17 minutes. Let's see if we can keep going. We're getting really close. We're getting really close. So let's turn off the things that we don't need anymore. All right, we need to do a reparameterized. So let reparam equal self.reparameterize. And we're going to pass in the FCMU and the FC var. And I think those need to be addresses or references. There we go. Because they are tensors. The Matrix Explained is a good YouTube channel for breaking down the Matrix. I would need to check that out. I would need to see it. So that way I get the full picture of the lore. I think that would be great. All right, our reparam worked. Now what do we do with our reparam? Now we can do a return on a decode input and then these things. So we get a Z. Okay. So we need to run it through decode. So now we need to write our decoder. Flatten out, not pooled. The pool does nothing. Computer won't catch it. You'll hit a shape mismatch at runtime. Yo, wait, let's try it. Are you sure? Cargo run. Wait, cargo run. Here we go. I get cargo run. Here we go. All right. It looks good to me. No shape mismatching. No warnings. Probably dead vars from the command. Yes. So these warnings that you see here are from the unused variables. Yep. Yo, Ramkey. Hey, what are we doing here? We're building a variational autoencoder in Rust. Some VAE. A little bit of variational autoencoding. Yo, how's it going there? GG, Maisha. Thank you, GG Maisha, for subscribing and joining the right channel for software engineering. Currently, we're building a variational autoencoder today. A little bit of VAE to draw a picture of a cat. That's what we're doing today. We're going to downsample the cat size so it can fit through a small neural network that can run on our local computer that is, somewhat powerful, but not very powerful. Powerful enough to be able to deal with this. And we're going to get it to draw the cat. We won't finish today. We will finish maybe this week. We might finish on Friday. So right now we're just doing the neural network part of it, which is the whole point, really. Random machine learning wizard has appeared. Hey. All right, we're on the right track, I think. Yo, Akash. Hey, Akash, good to see you. Welcome on in. Happy Tuesday. Good to have you here. Okay. So now that we're at this point, and it runs through, and it does our forward correctly, I need to write our decoder. So let's get our decoder going. All right, function decode and self. And I think we need just a single tensor, right? All right, so this will be our input, and it will be a AND tensor. And then we're gonna return a result of a tensor, probably. I assume. This is gonna want more than one thing. Let's find out. Oh, we still have to write the loss function, my goodness. All right, we have got a lot of work to do. Generate, sample. Where's the decode at? Here it is, decode, okay. So does that look right? Yes, okay. Looking good. Yo, how's it going there? Large Bug, good to see it. Large Bug. Welcome on in, Large Bug. Good to have you here, happy Tuesday. So that is just a straightforward input here, input. Decoder input, so we've got a linear layer. We change the view. We run decode again. Wait, decoder layer, the decoder layer, and then the final output layer, okay. So these are things that we're gonna have to get going here. What you writing code for? Yo, Accidental Genius Gamer, good to have you here. Happy Tuesday. We are building a variational autoencoder for learning how to do these things. We're learning it. We don't know how it works, and we're gonna figure it out along the way. We're currently using the Rust programming language, and we're converting some Python code that you see over here into Rust, using the Rust candle library. That's what we're doing today. And we're gonna have it draw a picture of a cat. That's what we're doing right now. Okay, let me see, where did we leave off? I needed to find my decoder. Decoder, well, see, here's the problem. The VA already has a decode. Well, I have a decode function though. So that should be fine. Function decode, perfect. All right, here we go. Okay, and we're gonna say we need to return the tensor. So let self.decoder input, question mark, okay, output. I'll just say out equals. See if that does the trick right there. Yo, Ashford, good to see ya. Welcome on in, happy Tuesday. I just saw you saying hello there. Finally, your Wi-Fi is working. Hey, Lily loves snow, good to hear it. Good to hear it, all working and happy. Excellent. All right, method decoder. I sure do have a decoder. I most certainly do. See, it's right here. Decoder, right there. It's in my struct. It's a conv2d. Right there, it's conv2d. If that's the case and it is a conv2d, then I think we need to do a little bit extra stuff here. I think this needs to be extra. All right, let me see here. Encoder. No, I'm just gonna keep that right there. Fine, so good. All right. So no method name decoder. Oh, we have to do a forward. All right, dot forward. There we go. Much better. Okay. Now that will probably fail because the shape isn't correct. However, so we are going to say let out equals self.decode, and we're going to pass in the reparam. Question mark. There we go. We're going to return the out. Okay. Mismatch. Oh, wait. Right. There we go. Hi there. I'm new to this channel. Yo, Power Washer 5918. Good to see you. Welcome on in. The channel is Software Engineering. We're currently writing programming in Rust. The Rust programming language is a systems level programming. I struggle with Python, so I figured I'd spend a bit of time watching this. Hey, good to hear it. We actually do have Python on the screen. Right here's some Python and this little window up in the top corner of the screen here. This is a variational autoencoder that we're using as reference to convert over to the Rust candle library. Yo, your Google Assistant. Hi, good to see you. Welcome on in. Really looking forward to the Rust VAE. Any chance you'll open source it? Yes, it's we'll open source it right now. So git status, git add, git commit, current progress on decoder as next step. Push that to the main branch. Yo, TG Pushy, Pishu. Yo, TG Pishu. Hi, good to see you. Welcome on in. Happy Tuesday. I will paste this over for you here. I believe, where is it at? Right here. So here's our code. I will send this under link share. Is this all we've done so far? That can't be right. Oh, it is right. Look how little code we've written. It's so small. It feels like it's been epic. It feels so much more epic. I'll put this over on our link share on our Discord. There you go. Open source. Thank you so much. Absolutely. I really like building code that is short and efficient and clean. I do a lot of code reduction. So a lot of the code that I write is going to be minimal looking, but very powerful. What are you trying to build? Variational autoencoder. This is going to be able to draw a picture of a cat. So we've got our VAE here. We've defined it, and we're going to have it draw the picture of a cat. Good Tuesday. Yeah, all right. Good to hear it. Good to hear it. We got 8 minutes. We're good to go. So now that we've got our output on our decoder here, how can one learn to code? Accidental Genius Programmer, I recommend starting with some Python tutorials. Python tutorials, go to python.org and then type in, or W3 Schools is another one. Pranjul, hey, Pranjul Flows. Refactoring in mind? A little bit. I do a little. So that's one of the things. When you want to learn coding, what I do is I might refactor another program. I will learn it, I understand it, I'll simplify it, make it better and faster. Refactoring is a good way to learn. You like your coding style? Nice. Thank you, Sergio. Or C, Torva makes a good point. If you are looking to be a systems level programmer and you want to understand data structures and algorithms, C is a good programming language to learn. Nice to see you reading all the comments. Yeah, Ramkey, absolutely. That's why we're here. If otherwise, I would just do this off stream. I wouldn't code on stream without reading your comments. Refactor is a good way to learn. Well said. Thank you. That's what we're doing today. All right. So did we get this working good? Okay. So we got our decode here, and we can add that into our forward, which we did. We got our decode there. Now, what else do we want to throw in the decode? This is going to be a, what do you call it? Input mismatch on the shape. So we want to print the shape here. Let's grab our shape on both of these sides. So we're going to grab our shape for the output. Oh, this is going to be out. It's going to fail, though. That'll fail. And then I need this to be the output for my input. All right, I need the input. Here we go. Much better. All right. Boo, boo, boo. All right, this is decode. Right here, a little bit of decode right there. Kotlin's good. Yep, Kotlin's pretty good. Hi. Hey, I was going there. Roxy Can Do. Hey, Roxy Can Do. Good to see you. You've not done any programming since cool in the mid 80s. I need to learn. Oh, yeah. Roxy, always a good way to do that. Pain when you have 80K lines of code, though. That's true, GoGo. If you have 80,000 lines of code and you want to do a refactor, challenge on the way. Cobol, yo, Roxy.
So expensive, but I love the ease of use, but can't afford 1,500 a month. Lol, sat TBH. Kimi K3 has been good. What do you use?
Okay, good question. Yo, Matthew Kaiser, thank you for the $5. Hey, that's a man. Yo, thank you. Yo, that was amazing. My gratitudes to you. Thank you very much. I have to reply. I have to click the reply button on that. Yo, thank you. All right, yo, at Matt. Yo, thank you. Explanation point party poppers. Hey, appreciate it. So we've got an answer for you. I have to spend time on, because you donated $5. Free coffee, right? Free coffee. Yo, Matthew, thank you. So what solution to Replit is so expensive, but I love the ease, and you can't afford $1,500 a month. It's expensive, right? So using Kimi K3 locally, that's a very good model. GLM52 is also a good model, though it's very big, so you need a very big, expensive computer for that. I use myself, I don't use any local models. We have something called AWS Bedrock. So I use AWS Bedrock. AWS Bedrock. That is a serverless compute Amazon provides you to run most of the common models. So you can run ChatGPT models, you can run Anthropic models like Opus, and you could run Google's open source models like Gemma. You can run GLM, and you can run Quinn and Kimi. You can run all the models. You can run them all. So that's what I use. I use AWS Bedrock. There we go. Excellent. Let me know if I miss any of your chats, you guys. I'll be happy to answer them. Does it do what Replit does? Can it self-test and self-setup? Oh, yes, it can. If you use it with, so I use it with Claude Code. So yes, if you use it with Claude Code. Not to say that this is a cheap solution though. It's not cheap. You're still going to spend money on it. So it still costs per token. It's not a per monthly bill. It's not like a flat fee. It's a per token price. So you pay per token. Yes, if you code with Claude Code CLI, then that's what I do. That's what I do, you guys. My time's extremely valuable to me, and I'm always trying to prioritize according to justify everything to meet immediate goals. But maybe that's the wrong mindset. No, it's good. I think you're good. You're on the right track. My point is, a lot of these projects, devs do seem related to 20-year goals or something. They are. It is a long game. It really is. It is a long game, you guys. It is absolutely a long game. What about Muse Glimmer? I've never heard of Muse Glimmer. What is that? What face cream do you use? I use water and soap. I use water and soap and what do you call that? Cetaphil lotion? Cetaphil? I made your own model. It lacks due to the needing more better JSON files. Oh, and more compute power, but it worked kind of. It fetches info when you type it. Nice. Hey, go. That's fantastic. Good to hear. Yo, Ramkey. Thanks for the heart. Hey, Lily Love Snow, welcome on back. What are we making? We're building a variational autoencoder. We're using Rust and the Candle library, the Rust Candle library, to build a variational autoencoder. It's going to draw us a picture of a cat. Draw us a picture of a cat right there. And we are partway through. We're making it really fast. We made a lot of progress today. We're converting a PyTorch example of a VAE into a Rust Candle version of that. We are making a lot of progress today. Quite a bit of progress. So let's see here. Where are we at? We finished here. So the problem is if I run this now, it's going to be the wrong shape. Let's double check this here. All right, so run. It should say shape mismatch. There it goes, yeah. Unexpected rank, expected 4 got a different rank. Okay, so we need to figure out how to fix that. Decode input 1/8, and then what is our decoder? Our decoder needs to be different here. All right, Discord link, please. All right, Ramkey sounds good. And then we are gonna wrap up here. 1 second. All right, Discord. All right, just for you, Ramkey. All right, you guys. So Ramkey asked for this Discord. Here we go. Discord just for you. Time to check your group chat. All right, sounds good. That's really brilliant. Your mind must be torturing battle against yourself. Sometimes, Lily. Sometimes, yeah. How did you know? All right. Thank you guys so much for joining. I do have to wrap up here. We'll continue on with tomorrow with more variational autoencoder. That's the plan for tomorrow. I got to go to a meeting now. We've got a meeting heading up here. It was a lot of fun. Thank you everyone for joining. I'll be back tomorrow. More VAE tomorrow. Take it easy. Enjoyed the show. Thank you, Gogo. Appreciate it. Have a beautiful day. Sergio, thank you. All right, you guys. Thank you. Hey, you're welcome. Absolutely. Thank you. See you guys. See you, Bonzupi. See you, Abhim Manny. Thank you, Abhim Manny. All right, bye, everybody. Have a good rest of your day. See you tomorrow. Thank you. Absolutely, Ramkey. Have a good... See ya. Bye, guys. See you, Joe. Thank you. Take care, all. Bye.